continuous random variables. This is a random variable where the data can take infinitely many values, 5 to 10, 10 to 15, 15 to 20, etc. That is, a continuous random variable cannot take precise values but can be defined only within a specified interval. For example, if I am talking of 5 to 10, there are 4 values, frequency is 4, and for x interval as 5 to 10, I'm talking only that at this time. So what will that 4 value? It can be like 4.1, 5.1, 5.2, 5.3, maybe 5.9 also, or other possibilities can be 9.2. So these are the 4 values. So we can consider any of these values in between 5 and 10. So we are not sure that which values are there, only the boundary points are known. And therefore we can say that it cannot take precise values but can be defined only within a specified interval. Okay, here are some examples. So for example, you can say like a random variable measuring the time taken for something to be done is 5 minutes. Measured to the nearest minute could be anywhere in the interval 4.95 and 5.05 or 4.5 and 5.5. What does it mean actually? It means that, for example, you can say that it takes 5 minutes to reach up to 2 kilometer distance by bike from this point. It is not possible that you will reach to that destination in exactly in 5 minutes. It's not possible, in fact, in practice actually. So what happens, if it takes 5 minutes, it can be a bit more or less with some error. So error doesn't mean that there should be big difference. There will be a small difference in the expected time here. If you say it takes 5 minutes, then you are talking of some interval of time, more or less. More or less means if there is very small error of, for example, you can say that the error of 0.05 minute, because we are talking of minute, 0.05 minute. In that case, what you can do, like more or less means less than that means you deduct this 0.05 from this number, then we have this value, then you add the same number to the 5, that will be more, and then we'll have another value. So roughly our time will be between 4.95 to 5.05. For example, if you are taking up to two significant figure or to only one decimal place, if there is a little bit big error in the time, for example, so in that case you can take out the difference as 0.5 only. So this is the general tradition in mathematics and statistics, that we take very small difference between the intervals. If you are talking of a time 5 minutes or 10 minutes, something like this. So here again we can deduct this 0.5 from 5, then we have 4.5, and if we have the same value we have 5.5. So more or less a difference of 0.5 minute if you say, then our interval will be like this. So this is not necessary, not compulsory to stop to only one number. It can be like difference can be like 0.1, more or less 0.01 second. It is also possible that you write 0.00 1 second. It is also possible that you take a difference of more or less if you are talking. So what level of accuracy you want to reach, it depends on that, 0.005 and etc. So if you are talking of less than that, little less than that, then you deduct this number from the given time or given number. And if you take a bit more, then you add the same number, and then we'll have interval form like this. And same thing happens here. So this type of variable is associated with measurement of characteristics such as time, mass, or length. Now we shall talk about probability density function. So just like the probability function for the discrete probability distribution, we say this is probability mass function. So here, if x is continuous random variable, so the probability function for this continuous random variable or the continuous probability distribution, so that probability function is called the probability density function. So here you can see it says that the probability function of continuous probability distribution is called probability density function. Distribution of probabilities based on continuous random variable, for example, say x, is called continuous probability distribution. So here x is defined by its probability density function fx, and it can be illustrated by the graph of y equal to fx, provided that total probability is 1. So here in this case, you can see that the probability in continuous case, random variable case, are expressed in terms of a continuous function, and the total probability in case of discrete random variable, we used to add this distinctly, like p1 plus p2 plus dot 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 up to pn, for example, and that used to be 1 here. So we, in the discrete case, we add them individually here at different point, and hence we find the total probability as 1 in order to say x as the random variable. But here in this case, instead of adding them directly, because this is the case of continuous, so we integrate the given function under the given range of value of x. So x belongs to R, means this is the real number case, and x can have some defined range of values. Let's now discuss some examples that demonstrate what is the probability density function, or what is the probability function for continuous random variable. So here in this case, let's suppose that a function is like this. This is a continuous function. So ft equals to 3 by t4 for t is greater or equals to 1 and 0 otherwise. What does it mean? That ft itself is the probability in the form of function, and it is defined as 3 by t4. And it says that 3 by t4 is only for t is greater or equals to 1. That means it's for the value of t greater or equals to 1 only. And 0 otherwise means what actually? So actually, if you talk about this curve mathematically, it will go like this, and go near and near to the y-axis, and but never touches. That means it shows asymptotic nature about the y-axis mathematically, but statistically it is defined in some given range of the weighted value along x-axis here. So that means 3 by t4 is defined for t is greater or equals to 1 only. For the rest of the thing, there is no probability defined. That means probability is 0. That's why it is written as this is 0 otherwise. Now we are talking about the total probability. Total probability means we add up all the probabilities 1 and beyond. So how do we add this in a continuous form, in the functional form? We always integrate the area under this curve. So if you find this area between 1 and infinity, then it will give you the total probability. So by using the law of, or by using the idea of integration, so you can, instead of writing sum, you can write sign of integration, and then it starts from 1 and will go to infinity, and your given function in this case is 3 by t to the power 4 and then ds, and in fact this is 1 to infinity ft dt. So here it is t, so we write here t, so this is dt. Now let's integrate this function. So t will be taken out, and this is 1 to infinity, and then it is t to the power negative 4 if you use the reciprocal thing here, and this is dt. Next step will be just integrate it. So it is t to the power minus 4 plus 1 divided by minus 4 plus 1, and then in the range 1 to infinity. Let me take this here. So we are going to find infinity to the power minus 3. It means you can write 1 by infinity to the power 3, and any power infinity will again be infinity, and finally this is going to be 0. So here in this case, it's going to be, this value is going to be 0, and this is 1 in fact. So this is 1. So any power to the value 1 is 1 itself. You can see that in front, when you cancel it, we are left with this negative sign. So it will be here. This is negative sign, and this is negative sign is here. So negative 1, negative sign plus another negative sign will make it positive, and finally the total probability is 1 in this case. So as the total probability, we have found this as 1, therefore t is called the random variable, and in this case this is the continuous random variable. So we can say this variable as random provided the total probability is 1. We have another example here, and in this example it says that the continuous random variable x has probability density function given by fx equal to this k, which is defined between a to 10. 0 otherwise means it is not defined beyond this interval value of x. So here k is a constant, it is known that probability of 5 less than x less than 8 is equals to 0.5. So this part is also given. So based on all the information, you have to find the value of k and a. If you draw a graph of this function, so your function is fx equals to k. So it is a constant function. It is a constant function, just like here we have seen this is 1 by 6, px equal to x equal to 1 by 6. So if you draw the graph of this kind of function, your graph will look like this. There will be some positive value of k. Here on the y-axis, k cannot be negative because the probability cannot be negative, and this is 0 for example. And say this is 1 because the value of probability cannot exceed 1. Okay, then if this is a constant function, so this value is k somewhere in between 0 and 1, and your graph will pass through point k on the y-axis parallel to the x-axis. Alright, so this is the mathematical graph for this function. But what it is statistically? Statistically, if you say that fx equal to k, statistically we can say that fx equal to k between a to 10 only. So if you are talking something beyond that, this fx doesn't exist there. Therefore, we call that fx equal to 0, otherwise. So this is, if this is 1, for example, if this is 1 and then this is 2, up to, we talk up to 10 is here. A can be somewhere in between, A can be here also, for example, this is A. So this sort of function is defined statistically between x values a to 10. So this is valid for start from a and ends to that. So statistically this is defined in this rectangle only, but mathematically it is defined for all x values. You can see now it says that where k is a constant, now it is known that probability of 5 less than x less than 8 is 0.5. Then we have to search somewhere 5 and 8 here in our graph. So dot and say here is 8 for example, sorry 5 for example here, and then another 5 6 7 8 for example here, and then it is telling you that between 5 and 8, although the figure is not to the scale but you can understand it, although between 5 and 10 the area is given as 0.5, that is 50%. So if it is a continuous function, then how do you find this area? You have to integrate the given function for the value of x between 5 and 8. So here you can see, like here it is given that p5 less than x less than 8 equals to 0.5, and then it means you integrate the given function from 5 to 8, and your fx value is k in fact here. So fx value is k, and then dx, and it is given as 0.5. We can also write 1 by 2. What we have done actually, we have actually integrated the given function from 5 to 8 fx dx, and from 5 to 8 it is given that is the 50% value in fact in this total area. And now let's integrate it now further. So it's going to be k is constant, so you can take this out. So it is 5 to 8, and then dx, this is dx means 1 dx equals to half. Then it is k, integration of 1 is x, if the variable is x, it is 5 to 8 equals to 1 by 2, and then you have k. So here you require the knowledge of integration, actually the definite integral. So here it is 8 minus 5, and this is going to be half, and then it is k times of 8 minus 5 is 3 equals to 1 by 2, and then finally you have k equals to 1 by 2. As it is multiplied here, it will transpose to the right, it will go to divide. So here times it is 3, so it is divided here, and therefore your value of k we have 1 by 6. Now we have already obtained the value of k. Now it is saying that we also find the value of a. So value of a, your given function is defined for the value of x between a and 10. So if x is the random variable, the total probability must be equals to 1 in order to say x as random variable. And the total probability has been defined in the range of value of x from a to 10, and you can write fx dx equals to 1. That means we are talking of this entire area now, and that covers the whole 100% of the area. So here now we have a2 and then minus a equals to 6. 10, if you transpose to the left, it is minus 6, and then if it goes to the right, then it will be plus a, positive a. So therefore your value of a in this case is 4. Therefore the value of a you obtained is 4, and the value of k you calculated as 1 by 6, and these are